Welcome, Hornets. In this video, we're going to be taking a look at uh, local or relative extrema as compared to global or absolute extrema. So, according to the extreme value theorem, if I have a continuous curve from two endpoints that are defined, then I have to have both an absolute maximum and an absolute minimum on the interval. Now, the way this works is the absolute minimum is the lowest point on a graph, and the highest point is referred to as the absolute or global maximum. So, absolute or global minimum, absolute or global maximum. Along our journey from one to the other, if we encounter a a value that is maximum relative to the points around it, or a minimum relative to the points around it, we call those local or relative extrema. Now, these occur when our derivative is equal to zero, and they are referred to as critical values. And that's one of the things that we have to be aware of. A critical value is where a derivative is either undefined or where a derivative is equal to zero. Now, this comes to play when we start talking about absolute maximums and absolute minimums, because here is an example of an absolute maximum at a critical value that doesn't exist. So here we're looking at a critical value on the function f, and this is where the derivative of f of x does not exist. Now, just as easily, we could have a relative maximum at a critical value that does exist. Now we have a derivative that equals zero and does exist. We have something that is smooth and differentiable. So be aware that when we talk about absolute maximums, absolute minimums, we have to look at what are the endpoints, and we have to check them. So the basic procedures for determining whether you have an absolute maximum or absolute minimum or locating where they are is step one, find all of your critical values. And then at those critical values, find the y for it to see if you're looking at a situation where the absolute maximum is a relative maximum. Or are you looking at a situation where the relative maximum is not the absolute maximum? Or where the relative minimum is not the absolute minimum? So you have to first figure out where the critical values. You then have to find out what are the values at those critical values, and then find the y values at the endpoints. And these will help you to determine what kind of a situation you might have. Are you looking at a situation where your absolute minimum is also the relative minimum? Or are you looking at a situation where the absolute minimum is not the relative minimum? And that it goes with the absolute maximum. Here we have a relative maximum and an absolute maximum. Here we have a relative maximum and an absolute maximum. Here we have just an absolute maximum that is a relative maximum. Okay, now we could draw all kinds of points, and it's when we start to draw the points that you have to be even more careful. For example, this graph has no absolute minimum because I never reach the endpoint. This would be an open interval a to b. And in the open interval a to b, we no longer have an absolute minimum. If we put it on the other end, we now have no absolute maximum. And we're now looking at a to b with parentheses. Okay, so be aware. Just because you have endpoints doesn't mean you have an absolute maximum or absolute minimum if one of those endpoints doesn't exist. All right. So here is just some of the basics of this. And each situation you're going to have to consider carefully. As we continue, be aware we are going to be finding absolute and relative maximums. As we do so, we will make tables of values so that we can locate our critical values and find the y values at them, and then find the y values at the endpoints. Remember, we're always checking endpoints and critical values. Alrighty, thank you very much. I hope this was helpful and informative, and we will be continuing with this as we go. Thank you very much, Hornets. Be well, be safe, and take care.